Okay, let's give you guys some practice. So where in 3D space will these two lines intersect? So imagine this line as this. So this line here is this line here. So this point here is floating in the middle of nowhere in 3D space. So this is your X, Y, and Z. It's floating. This point is floating in the middle of nowhere. In fact, it's badly drawn because you've got a negative here. So Z is somewhere down here. But let's just imagine it's that. Let's just imagine that this point here is right here. So this vector here, let's just imagine it to be like this. So if you put a 3 into this t, it will be 1, 2, 3. It will take you to here. And then this point here is, let's just imagine it to be here. And then let's just imagine this vector here as this. So if you put a 2 into the s, if you put a 2 into the s, it will be 1, 2. It will take you to here. So find the location of where the two lines will intersect. So press pause and have a go. Okay, so to do this, if the two lines truly intersect, then the x, y, and z location of the two lines will be exactly the same. So looking at the equation for this line, the x location is this. This is your x location. So you can imagine x as being this thing here, 5 plus t, and then the x location for the second line will be x will be 2 plus s. So at this point here, the x location for this line will be the same as the x location for this line, and the x location for this line. And at the point of intersection, the y location for this line will be the same as the y location for this line. And then at this point, the z location for this line will be the same as the z location for this line. In short, this is your x here. So in short, this is your x for the first line. Hang on, bear with me. Hang on. In short, this will be 5 plus t, and the x location for this one will be 2 plus s. So at the point of intersection, the x coordinate must be the same as the x coordinates over here. And then at this point here, 2, and then minus 2t must be the same as 0 plus 2s. And then at this point here, negative 1 minus 3t must be the same as 4 minus s. 4 minus s. So now our job is to find. So at this point here, this must equal this. This must equal this. This must equal this. So that will then take us to here. So we are looking for a value of t and a value of s for which all three will be satisfied. So looking at this, we are looking at. So remember, what's happening here is, hang on, bear with me. What's happening here is that this thing here is this vector here. So when t equals 3, it will be 1, 2, 3. It will take you to here. This vector, let's say it's here. If you put a 4 into here, it will be 1, 2, 3, 4. It will take you to around here. So we are looking for t, a value of t, and a value of s for which all three will be satisfied. So we are looking for a value of s and a value of t for which all three will be satisfied. So it's really trying to find out s and t now. So basic high school mathematics now, simultaneous equations. So looking at this, times, well, you can see that if you get these two to be the same, times everything here by 2. So this will be 10. Well, times everything by 2. This thing here will become this. Okay. So this whole lot will take you to here. So now looking at these two, well, if you add these two together, this whole thing here will then become this. So adding these two together, that will then give you this. So that means S must equal 2. Looking at this, S must equal 2. So now that you know S equals 2, you put it back into here, and then T must equal, hang on, you put the 2 back into here. So this thing here will then be 2, this thing here will be this, so T must be -1. So, well, do whichever method you want. So from here, you're just looking for values of T and S in such a way that all three equations will be satisfied. Well, it turns out that S equals 2, T equals -1. So what that means is this. So it turns out S equals 2, T equals -1. It turns out that what it means is this. What it means is that we've drawn our diagram badly, because right from the start I said that we were floating in the middle of nowhere. If you were to draw it properly, it would probably, this point would probably be somewhere around here. This point here would be around here, rather than here. It will be here. Hang on, bear with me. Rather than starting here, it will be here. Bear with me. So what it means is, because T is -1, if you look, you've got to put -1 into here. So this is our T. This is our starting location here. So you've got to imagine this vector here as something like this, So if you put a 3 into here, it will be 1, 2, 3. It will take you to somewhere over here. But here it's actually -1. So what that means is it will, because this is our vector here, -1 will then take you to here. And then when you put 2 into here, so your starting locations here, let's just imagine this as this vector here. So when you put a 2 into the S, it will be 1, 2. It will jump to here. So when S equals 2 and T equals -1, or this line here will take you to this point. And then when you put a 2 into the S, this point here will then take you to here. So this will be this is the time at which the two will intersect. So if you want to know the location, then put this into here. So the location in the X direction will be 2 plus, well, put this into here, so that will be 2. So the X location will be 4, and then the Y location will be, well, put the 2 into here, so it would be 0 plus 4, and then the Z location will be, well, put this into here. That would then be 4. So the Z location will be 4. Put this into here. This will be 4 minus 2. So that will be 2. So that will then give you your precise location. If the two lines don't intersect, when you're trying to solve this, when you're trying to solve something like this, on your third equation, you're going to get something ridiculous like -3 equals 5. If the two lines don't intersect, you're going to get something silly like this. But if the two lines do intersect, then you're going to get something nice and neat, which is S equals 2, T equals -1. Okay?